Hi everyone, welcome to our channel Code with Sunny, and today I am going to discuss the problem shortest unsorted continuous subarray of Leetcode, and the index number is 581 and the problem is of medium type as you can see here. Okay, so let's discuss the problem without wasting our time. So basically we have been given an array of integers and we need to find the continuous subarray, one continuous subarray, such that after sorting this subarray in ascending order, then the entire array will be sorted. That is, entire array gets sorted in ascending order if we sort this subarray in ascending order, and we have to return the length of that sorted subarray. Okay, so let's look on the constraints also. Our array length would be vary up to 10 power 4 and the values vary up to minus 10 power 5 to 10 power 5. Okay, so n log n approaches will pass and O of n will surely pass, O of n square will fail. Okay, so let's analyze this problem further without wasting our time. So what is actually given in this question? Let's understand this also. Okay, so basically we have been given an array of n elements. Find the length of the sorted subarray of this array, which on sorting makes the given array sorted. Okay, sorted in ascending order. So we have to find the length of that sorted subarray. Okay, so let's jump directly into the problem statement, or you can say examples, how we are going to do this. Before discuss the examples, let's first discuss what this actual sorted subarray, sorted array means. Okay, suppose we have an array like this. Okay, note that this array is sorted in ascending order. So what is the key observation that you can find here? That is, for any index there are two observation. Okay, two, let me write two key observations. Okay, so what are the first observation? Okay, for any index, let's pick up the index with a value equal to 4. Okay, so for any index, for a sorted array, let me write, for a sorted array at any index, let's say we have an array of index, then that value, then we can write array of index is greater than or equal to array of I for every value of I what, less than equal to index. So this is the key observation that you can see. Suppose here we have 4, then all the indexes that are less than or equal to my current index, that is I and dx, and we are going for I, then all the values that are less than this have index what, less than equal to this. And we have one more observation, that is that for a sorted array at any index we can have array of index. Now array of index is what, less than or equal to array of I, we can say, for every what, for every value of I greater than equal to index. That is, for a given index, let's say we have I and dx, then this value will be the maximum value for all the values that are less than or equal to the my current index. And similarly, this value is what, minimum among the all the elements that are present to its right. Okay, so this is the main key observation. So this is for sorted array. So in what if in case we have a unsorted array like this? You can see, let's now discuss my examples. Suppose we have an unsorted array like this. So let's first sort this array and let's see what is going to happen. Okay, now this is a what, my sorted array. Okay, now you can see 2 is in its correct place, 4 is not in correct place. 4 in 4 is in place at index equal to third, and here it is in sorted array index equal to 2. Now you can see 4 is not the element. If 4 is in its correct place, then all the elements that are going to less than or equal to the 4 must lie on its left, and all the elements that are greater than or equal to 4 must lie on its right. That is, you can see here. but here it is not the case. 6 is greater than 4, so 4 is not in its correct place. And similarly you can find other elements also, that is let's move consider 6. Now in a sorted array, all 4 and 2 is lying on its left, and now but in unsorted arrays, 2 only 2 is lying on its left, so 6 is not in its correct position. So what I am going to do is, let me write a simpler approach is sort the given array. Let me write, make the duplicate array, then sort it and find the first index from left which is mismatched. So you can see first elements from its left which is mismatched is 6. 6 is not matching with 4. So I need to sort this array starting from this one. Okay. And similarly, if we move from its right, then we can also write find the, let me write, first element from the right which is mismatched. Okay, then we can see we have a value 10 and we have a value 9. So our answer is we need to sort this amount of elements that is necessary to sort, so that our entire array can be sorted in ascending order if we sort this subarray. So our length of this array would be what? Sorted subarray would be what? 6, 4, 8, 10, 9, and its length is 5. So but in that case a simpler approach is taking on the space. What about in solving in O of one space? Let me write. So if we want to solve my problem in O of one space, then we need to have the knowledge of what? This what observation: for a sorted array at any index, array of index is what? Greater than equal to array of I for every value of index I less than equal to index. Similarly for this one also, second observation. So what we need to do in this case is, for O of one space solution, we are going to find the last element, find the index of the last element. Let me write, find the index of the last element which is smaller than the maximum found till yet. So we are going to find the index of the last element which is smaller than the maximum found till yet, because we know that for the sorted array we need to have all the elements to its left must be smaller than the current index element. Okay, so we need to find the last element which is smaller than the maximum found element till yet. So if we consider this array, then you can see the last element is 9, because before 9 is the last element before which we cannot find the element. That is, if we can see 15, then 15 is the maximum element and all the elements is less than equal to 15 to its left. So 15 is satisfying the criteria for a sorted array. But if we look at 9, then 9 is the not satisfying its criteria, because maximum element till we can found is 10, but here we are going to find 9 which is not satisfying our criteria. So 9 is the last element. And similarly, if we look at from the left hand side, then you can see 6 is the last element which is not satisfying the criteria. That is, if we iterate from the right hand side and find the last element which is not satisfying the criteria, then 6 is that element which is bigger than the minimum element found till now from the right side. So if we look at the minimum element found till now, that is till up to 6, it would come out to be 4, but 6 is greater than 4, which is not satisfying the criteria, because we need to have the element such that all the elements to its right must be greater than or equal to, but 6 is greater than equal to 4, so this is not satisfying the criteria, but 6 is the last element we have found from its right. So we have encountered the two elements, that is what? The beginning index and the ending index. So we have to find the length of that segment, so that would be our answer. So let us first analyze this without what we can say some examples also. So you can see, let me start from the here, that is from the left side, and find the max last element which is not satisfying the criteria. So if we come up to 2, then maximum element up to 2 is what, 2, and 2 is and all the elements that is left side of the 2 is what, that is no element, so 2 is satisfying criteria. And now we come up to 6, then 6 is the element that is satisfying the criteria, because 2 6 is what, in ascending order. And if we come up to 4, then maximum element found up to 4 from the left side is 6, and 4 is not satisfying the criteria, that is 4 is not greater than or equal to 6. So we have found an element called 4. Okay, now let's move further, because you have to find the last element, because now you can see 8, then 8 is also satisfying the criteria, so we have not we are not including the answer for 8th index. And similarly, if we come up to 10, then we can also see 10 is satisfying, so no need to include that. And similarly come up to 9, but you can see 9 is not satisfying the criteria, because all the elements to its left is what, is not greater, or you can say is not what, smaller than 9, because 10 is, you can see 10 is what, if we found the maximum element up to 9, 10 is the maximum element, but 9 should be greater than 10, but 9 is not greater than 10, so we are going to include 9 in our answer as the last element. Okay, and again from here itself you can see all the elements are satisfying the criteria. So what is our last element? Let me denote it with e value. So I am going to denote it with e last element of let me find the index of 9, that is 2 6 4, that is 0 1 2 3 4 5. So our last element index would be what, 5. And if we consider this arrangement from the right side, find the minimum element, find the last element, such that the current index is what, uh, is what we can say, we here we can find 6, that is 6 is what, bigger than the all the element from its right. So 6 is the last element. So how we are going to find this? Let's move from right side. Note that 19 is satisfying the criteria, because 19 is the minimum element for all the elements that are to its right. And similarly 16 is also the minimum element for all the elements that are to its right, that is 16 and 19. And similarly 15 is also the minimum element, you can see, for all the elements that are to its right. Similarly if you look for 19, 19 is also the minimum element for all the elements to its right. And if you look for 10, then 10 is not the minimum element for all the elements to its right, because 9 is the minimum element. So I am going to make my start as what, index of 9. Let me write I of, okay, 9. So no need to get confused. And if we look for 8, then 8 is the minimum element for all the elements to its right, so we are not going to include 8th index. And similarly if we encounter 4, then 4 is also again the minimum element, so I am not going to account for 4th index. And similarly if we come up to 6, then you note that 6 is not the minimum element, so I need to change the my start index, that is I have my updated start index as what, 1, that is the index of element 6. So I have found my start index and I have found my end index, and we need to sort this subarray. So our length would be what, 5, which is our answer. Okay, so let's move on to the approach. How we are going to note that here also you can find the length of what, you can have length of, let me write length of what, 4 1 3 5 4 2. We need to sort this, and this is already sorted array. Here you can find what, the length as 0, sorted sub array, because we know there is no need to sort this array. Now let me discuss my approach 1, which is the best approach I have found till now. This is going to use the time complexity of O of n and space complexity of O of 1. Okay, now note that sorted condition is violated when array of I is going to be less than what, array of I minus 1. This is the key point, and also the two observations that I have written above. Okay, now what I am going to do, I am going to mark my two pointers, start pointer and end pointer. Note that I am going to initialize end with -2, because suppose in the condition, note that finally what I have to print, if we note that I have to print my what, end minus start plus 1 as the what, length of the sorted subarray. So if in case we haven't found a suitable subarray, in case where our original array is already in ascending order, then this condition is going to give 0 if we take in int as -2. Okay, you can see -2 minus of -1, which is what, -1 plus 1 is 0. Okay, that's why I've taken int as -2, so that we need not to write any extra conditions. Now what I'm going to do is I'm going to iterate from the beginning and of the array and find the what? Find the last element which is smaller than the last seen maximum from its left side and mark it as end. That's what I have done here. As you can see, find the last element. It is going to be denoted by E. Okay. Now similarly, I'm going to iterate from the end of the array and find the last element which is bigger than the last seen minimum from its right. You can see here I have 6, then the last seen minimum is what? 4. Last seen minimum is what? 4. But you can see 6 is bigger than 4, so I need to account for 6 index, that is 1. So I'm going to find the last seen minimum from its right side and mark it as beginning. So I need to update beginning every time we found the violating condition. Okay, so our answer finally would be what? Int minus the start plus 1. Okay, so in this case we have a time complexity of O of n and a space complexity of O of 1. Okay, so let's discuss my approach 2, which is actually not good approach because it's taking a memory, and also time complexity would be n log n because of sorting. But this approach is has a benefit because this approach has helps the what you can say beginners to understand this problem and manipulate them and solve this problem in an easier way. Okay, so let's make another copy of the given array, and we are going to sort the duplicate array in what? Let me write in ascending order. So if we sort that my duplicate array in ascending order, then we need to find that our if our original array is equal to my duplicate array or not, and if it is not equal to, then what are the extreme indexes which are not satisfying the sorted array values. So let me find the first index from its left side, so which is not and also the from the right side where the duplicate array value doesn't match with our array value. So our answer will be int minus start plus 1 in that case, and our time complexity in this case will be n log n because we need to sort the duplicate array in n log of n time using STL function in C++, and our space complexity would be O of n because we are managing an extra array, duplicate array of size same as the original array size of n. That's why we are going to account for the space O of n. Okay, so let's discuss the code also. Okay, wait a minute, I have some network issue, I think. Let me account for that also. Okay, now it's connected. Okay, now I have done using two approaches. Let me discuss that also. So this is my first approach. Okay, now here you can see what I have done. Or no, sorry, this is my second approach. Okay, so I've so first make a duplicate array V and sorted this array, and now if V is exactly equal to nums, then our answer would be 0 in this case. And now you can see I have what? Find the first index from its left and named it as L. And similarly, if I have mismatched the condition with the sorted array, I have found that index, I have breaked it from for loop similarly from the right side and find the what difference r minus l plus 1, which is our answer. And let's discuss my what second, or you can say first approach, which is actually the 98% faster beats. Okay, no, so what I've done is if n is going to be less than or equal to 1, we all know that it is our answer would be 0. Now I'm going to iterate from the beginning of the array and find the last element which is smaller than the last seen maximum from the left side and mark it as int. Okay, so I'm going to initialize my int as -2 for simplicity, as I've already said. Now let us take a maximum variable that is initialized with int minimum. Now what I have done is I have started traversing the array and find the maximum, and if it is not satisfying the criteria of a sorted array, that is for every value, that is for every index I am going to check if it is what less than the maximum found till now, then this index is not satisfying. So I am going to modify my int variable. Note that for the index I to satisfy, from its left side, the current index is the maximum element for all the elements that are lying to its left. And similarly, I'm going to iterate from the end of the array and find the last element which is bigger than the last chain minimum from its right side, because for a sorted array, for any index I, this index element must be what? Minimum element for all the elements that are lying to its right. So I need to find that as a what? That index, last index. So I'm going to initialize begin with -1, minimum as int max, and find that minimum. Each time I'm going to find the minimum, check the condition if this is going to violate my condition or not. Finally, I'm going to print my length int minus begin plus 1, which is giving the correct answer. So what? Okay. So if you have any doubts, do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel for latest updates. Thank you for watching this.